Let's do some more implicit differentiation. Find the derivative for this equation. If you follow the steps from the previous video, you may have gotten that the derivative is negative x over y. But this was a trick question. Think about it. You can't add two positive numbers and get a negative. This equation has no solution points. There is no graph. You can't have a slope of a tangent line if there's no line and no graph to be tangent to. So remember this. dy by dx only has meaning as a slope if the equation actually has a graph, and that graph has to have differentiable segments. Let's try a couple real examples. Find the slope of the tangent line to this graph, let's say at point square root 2 and negative 1 over square root 2. This is a graph of an ellipse. It looks something like this. And we're trying to find the slope of the line that's tangent to this curve right at this specific point. So what's the first step? Let's differentiate both sides with respect to x. The derivative of x squared with respect to x, the derivative is 2x. What about 4y squared? What's the derivative of that with respect to x? Notice the variables disagree, so we need to use the chain rule. The derivative of 4y squared with respect to y is 8y, but we also need to multiply that by the rate of change of the inside, which is dy dx. Over to the right, the derivative of a constant is 0. Now let's solve for dy dx. Let's move the 2x to the right. And divide both sides by 8y. Reduce, and we have our dy by dx. Now let's evaluate the slope at the given point. Plug in the given xy pair. On the top, we have negative square root 2. And on the bottom, we have negative 4 over the square root of 2. The negatives cancel out. We can reciprocate this guy to the top. And the square root of 2 squared is 2. And 2 over 4 reduces to 1/2. This one's a bit messier, so keep track of your work. Let's find the slope of this graph at 0.31. The graph looks something like this. This kind of graph is called a lemniscate. Let's find the slope at the 0.31. What's the first step? Let's differentiate the entire equation. On the left side, we need to use the chain rule. What's the outer function? The outer function is 3 times something raised to the power of 2. And the inner function is what's in the parentheses. Bring the 2 down, multiply by the 3 in the front to get 6. Keep the inside function the same, and reduce the exponent by 1. The chain rule says we have to multiply that by the inside function. The derivative of x squared is 2x. And the derivative of y squared with respect to x is 2y dy dx. Over to the right, the 100 is a constant multiple, so we'll leave that out front. Now, how do we find the derivative of a product of two functions? Hopefully you said the product rule, which gives us the first function times the derivative of the second function plus the second function times the derivative of the first function. Now let's solve for dy dx. Our dy by dx is trapped in these parentheses. So how can we set them free? On the right side, we can distribute this 100 to the stuff inside the brackets. On the left side, we need to distribute this entire term and distribute that to both terms inside this parentheses. Here's our expanded equation. Let's get all the terms with dy by dx on the left side and all the terms without it on the right side. Now, both terms on the left side have dy dx in them. So let's factor that out. Now let's divide both sides by that big bracketed term. And we can simplify a little bit more by taking a 4 out of each of these terms. And finally, we can evaluate the slope at the given point, 3, 1. Plug in 3 where you see x, and plug in 1 where you see y. So the slope of the tangent line at point 3, 1 is 13 over 9.